Welcome to Ask and Learn.
In this problem, we have an airplane that has an unequal distribution of fuel in the wing tanks, and the center of gravity for the airplane fuselage wings R and B are located as shown. They have weights 45,000 pounds, 8,000 pounds, and 6,000 pounds. So the fuselage has weight 45,000 pounds, and each of the wings, one wing has a weight of 6,000 pounds and the other has a weight of 8,000 pounds, and that's because of the difference in fuel. And I want to determine the reaction forces at the wheels. So we have 3 wheels. So again, I'm not going to try to reproduce this schematic, but if you can look or reproduce the figure schematically here. But it's just a matter of writing down all the forces that are acting, and we have 6 forces acting, 3 applied loads from weight, and 3 reaction forces. So, and we're given a coordinate system, and I'm just going to use that to write my position vectors. And so, basically, what we see is that the z, how the vertical component of these position vectors is irrelevant. Because all of the forces are in the vertical direction. So when we take cross products with the forces, it doesn't matter what these values are. So the first load is a distance 7 feet from the origin, and this is the weight of the fuselage. Now we have a load that is 4 feet in the x direction from the origin, minus 6 in the y direction, and that is in the book that we call that point B. So that's the weight of the right hand wing, and the weight of the left hand wing, and the position of the center of mass of the left hand wing is farther out than this one. Then we have the reaction forces. So this is a reaction force at y equals minus 14. So that would be the reaction force at D, at wheel D. And then here's the reaction force at wheel E, and it's just in the opposite side, again along on the y-axis. And then we have the reaction force of the front tire at F, and it is 27 feet in front of the origin in the x direction. So really, it's just a matter of we have a lot of forces here, but we really only have 3 unknowns. These 3 guys here. We know what all of these are, and we know the position vectors. So we sum forces in a moment, set them equal to 0, and we get 3 equations of 3 unknowns. And we find that, strangely, these 2 loads are actually identical, 22.6 kips. And the load on the front tire is 13.7 kips. It's strange. I mean, it's strange that these are identical because we have the different amounts of fuel in each wing. But what happens is that because the distance away from the center of mass is different. So F3 is less than F. This is less than this, but this is greater than that. And so it turns out that those things just offset. And I think probably a plane is designed like that so that as fuel is loaded, it will try to keep the center of the moment caused by that fuel. So this keep the center of mass such that the moment caused by that fuel is the same as the moment is going to be constant, so that it'll be the same on both sides, on both wings. So you have a uniform distribution of the weight on the tires.